Hi, we are Team 5 and we are here to present our final project demo for ADS Summer 2017. The domain which was given to us was healthcare analytics, and we used a breast cancer dataset for our final project. So we have developed an application which enables the user to calculate their risk probability of getting breast cancer based on the input they provide, and then also it enables the oncologist or doctors to classify what kind of breast cancer the user is the user has got based on the input which will be given by the doctor. So I am logging in as user, and then this is just an general information or overview about what breast cancer is. And then this is the assessment page where the users can go and then key in the information. So I'm just giving a random input here. So here, and then if you could see here, I'm giving access. So here the probability of getting cancer is high and it is positive, and I can go back to the main page. And also for the user page, we have developed a dashboard where we are just showing an exploratory data analysis of metabolic data, which will show the trends of breast cancer patients, or the history of breast cancer with various factors, like say here this is the graph for cancer versus menopause state. See, people who are having cancer have post menopause is more than compared to the pre-menopause stage. And if you could see in this graph here, the white people and then the black people, and these two race are the people who have got a higher percentage of breast cancer than the other race, or other people from the other background. And we could see that people who are having the history of cancer in their family, like especially the number of first degree relatives if at all they have a cancer. And if you could see, there is a probability of probability of getting cancer is higher in this scenario. And I'm going back to the doctor login. So in the doctor login, again, this is an overview. And here in the cancer type classification, so these are all the parameters which the doctor or oncologist can enter, like tumor stage and tumor size, what is the tumor laterality, and what is the age at which the user was diagnosed with, and cellularity. And this ER, HER, and PR are all related to medical terms, which is estrogen status, which is be positive or negative, and this is PR is progesterone, sorry. And yeah, and based on this, we are classifying the output, classifying the cancer types, probability of which type of cancer for the given input is. And again, so here this again a different dashboard for the user. So this data shows that, see, for the most common type of cancer which is occurring in women is breast invasive ductal carcinoma. So and if you could see here, the probability or number of people who are getting cancer is getting higher in this region, from 50 to 60 or 70, and then it normally drops down on the other side. So, and if you could see, the invasive ductal carcinoma is most common occurring type of cancer. And and if you could see, it is also a deadly type of cancer, breast cancer type, where the survival rate is very less, and people who have survived this type of cancer is very less. And this is just an graphs based on the few parameters which doctors or oncologists could be helpful. I mean, for them it will be helpful. And moving on to the reports part. So as I said earlier, we are downloading the data from two sites, which is Meta Big Data and then BCSC research data. So the first step is web scraping and the data wrangling. So the data analysis part is done using Tableau and then Python, and then the web scrape data, and then the data wrangled data for handling missing values, and then removing any outliers is done using R. And then these two scripts are dockerized, and then we have used Airflow as a pipeline model to pipeline these two Docker images. And for building the models, we have used Azure ML Studio. So for the variable selection, we have used the Azure. We have used we have used both R scripts and then as well as the Azure ML blocks to for the variable selection. And then yeah, these are all just screenshots of the pipeline using Airflow. And these are all the screenshots for Docker images, how to dockerize the images. And then also we are putting the data into the Azure blob storage using the R script, and then accessing it. So this is the overall architecture or flow for the first part of calculating the breast cancer risk assessment. So we handle the missing data using mice, which is a block in Azure ML, and then we used rows library using ASCII for for oversampling and undersampling. We try to both do oversample and undersample the data, and then we used different algorithms, and then we found that the neural network algorithm was giving better accuracy than the others. And these are all the steps for that. And for the second part, which is for the multi-classification, classifying the type of cancer for the given inputs. So we used three algorithms. One is neural network, second one is random forest, and another one is as all multi-class SVM. So for this we found that the age of the people with the data set we had was normally distributed. And so instead of building a model for classifying this, we thought we could divide the data into two halves for the people which means to cluster the data, so that we could develop a model for people whose age group doing the diagnosis was below 62, and another model for people who are diagnosed with the age after 62. So the idea behind this is because there are certain types of cancer which was so that idea behind this is it could for the given input based on the age group, the model can even more accurately classify the type of cancer. And so for this model, for the variable selection, we used inbuilt Azure model, and we used feature scoring, which is chi-squared. And then these are all the features we had. And then for this, since we had two models, one model for each cluster, we have deployed random forest and then SVM based on their overall accuracy. And if we could see the model performance, the model was able to accurately classify the invasive ductal carcinoma and lobular carcinoma type of cancer types. But it was not classifying that better for the other two types of cancer cells. So this is because of the skewed number of rows or number of percentage of data for the IDC and ILC cancer types. We tried to balance the data using SMOT and R rows, but the accuracy was not improving. So we use the same dataset as such. For the deployment of the app, we use the Python class, HTML and CSS and JavaScript. So these are all just the screenshots for the application. Thank you.